Hello dear students, welcome to the discussion of electrostatics. In this video, we will discuss some problems about Coulomb's law. Okay, most of them are NCERT problems which are given in the exercise of NCERT textbook. Okay, let us go to the problems. This is the first problem. 4-point charges, QA equal to 2 microcoulomb, QB is equal to minus 5 microcoulomb. QC 2 microcoulomb and QD is equal to minus 5 microcoulomb are located uh, at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? So we have a square, and at the corners of the square there are 4 charges placed. Suppose this is square. Okay, this is square. At the corners of the square, let me remove the filling. Now fill. Okay. So at the corners of the square there are let it be, this is A, this is B, and C and D. Okay, so here there is 2 microcoulomb charge, then here at B there is minus 5 microcoulomb charge, and at C there is 2 microcoulomb charge, and at D there is minus 5 micro, just minus 5 microcoulomb charge. Okay, the side of the square is 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? So at the center of the square, 1 microcoulomb charge is placed. I'll draw like this. This is one of the diagonals, and this is the other diagonal. At the center, there is 1 microcoulomb charge placed. Now the question is, what is the force on this 1 microcoulomb charge which is placed at the center? What is the total force on this 1 microcoulomb charge? So if you consider this charges individually, let the 2 microcoulomb charge, let us consider the force on this 1 microcoulomb charge due to the 2 microcoulomb charge. You know, both are positive charges. This given 1 microcoulomb charge is a positive charge, you know, this also is positive, so there will be a repulsion. This 2 microcoulomb charge will repel this 1 microcoulomb charge along this line, right? This is the force applied by that 2 microcoulomb charge at A. Okay, now if you consider the opposite charge, which is opposite to this A, there is C. At the other end of the diagonal there is C. C means at C there is 2 microcoulomb charge itself. Okay, this 2 microcoulomb charge will exert a force. I will write it FC in the opposite direction, right? Because this 2 microcoulomb charge also is positive, and this 1 microcoulomb charge is positive, so there will be repulsion and it will be opposite to this. So what is the resultant of these two forces? The resultant of these two forces, the net, the two forces are equal and opposite. Okay, they are equal because both are 2 microcoulomb charges at the same distance. Okay, so Fa plus Fc, since they are equal and opposite, they will cancel each other. Similarly, if you consider the other two charges, this B, the charge at B is minus 5 microcoulomb charge, so it will attract this 1 microcoulomb charge towards its side. Okay, this is its attraction. I will write it as Fb. Okay, and opposite to this B there is D. At D there is a minus 5 microcoulomb charge. Same here also there is minus 5. Here also it is minus 5. This minus 5 also attract this 1 coulomb charge. So the force will be in the opposite direction. Fd. So if you add these two forces are equal and opposite, so they will cancel each other. That is Fb plus Fd will also be equal to 0. So what is the net force? Therefore net force means the sum of all forces Fa plus Fb plus Fc plus Fd, that is equal to 0. So the net force acting on the 1 microcoulomb charge placed at the center is 0. Okay, we are going to the next question. This is an NCERT question. Two insulated charged copper spheres A and B have the centers separated by a distance 50 centimeter. So we have two spheres and the centers are separated by 50 centimeter. Let this be the spheres. One sphere is this, the other one is this. Okay. Their centers are separated by 50 centimeter distance. Yeah, this is 50 centimeter. Or it is equal to 0.5 meter. In SI unit, it is 0.5 meter, right? So this is, let this be A, this is B. What is the mutual force of electrostatic repulsion if the charge on each is this? Okay, so let Q be the charge on each. And Q is 6.5 into 10 raised to minus 7 Coulomb. The radii of A and B are negligible. These two spheres are very small. They are very small. So their radius need not be considered. Okay, as compared to the distance between them. Distance is 50 centimeter. As compared to that 50 centimeter, their radii are very small. Okay, so this is the distance, you know. Okay, so we want to find the mutual force of electrostatic repulsion. Yes, we will calculate the force. Part A, we are doing the part A, then I will read the part B and solve, and I will solve it. So F, let it be F. The force will be, you know, if the charges are placed in a, the force will be 1 by 4 pi epsilon 0 q into q. Here both charges are equal, so q1 q2, instead of q1 q2 we have q into q divided by r square. Okay, you know, this is the equation of Coulomb's law. If you have not watched the previous video about the Coulomb's law, go and watch the video first, then come to these problems. So this is the magnitude, you know, it is 1 by 4 pi epsilon 0 q. Yeah, so it is 1 by 4 pi epsilon 0 q square by r square. We can calculate this. This 1 by 4 pi epsilon 0 is 9 into 10 raised to 9 times q square. Q square is 6.5 into 10 raised to minus 7 the square divided by r square. R square means 0.5 square. Okay, we can calculate this value. It is 9 times 6.5 square. When you open this bracket, it's 6.5 square. I will write the other terms. This is 10 raised to 9. And here, when we square this 10 raised to minus 7, it is 10 raised to minus 14. I will write it here, 10 raised to, because a raised to m, the into a raised to n is a raised to m plus n. Here it is minus 14, so I have written like this. In the denominator, there is 0.5 square. 0.5 square is 0.25, right? Okay. So you have to multiply these quantities and divide with this. And the power, you have to write the power also. So if you simplify this, this 0.25 is without calculator, you can do like this, 9 times. You have to find 6.5. Anyway, you have to find 6.5 square. 6.5 into 6.5. Divided by 0.25 is 1.25 is 1 by 4, right? So 4 comes to the numerator into 10 raised to 9 minus 14 is what? Minus 5, right? Minus 5. Okay. So this is 9 times 4 times this 4 comes to numerator into 6.5 square into 10 raised to minus 5. So I will calculate, this is 36 times 6.5 into 6.5. 36 times, let me calculate that. 36 times 6.5 into 6.5. The value is 1.5 to 1. 5 to 1. You can round off the value up to 2 decimals. So actually the answer is what I am getting is 1521 into 10 raised to minus 5. So in the standard form it is 1.5 to 1.5. I have taken the point to this point, so here I have to adjust. It is 10 raised to minus 2, right? Minus 2, this much Newton. This is the force. Okay, this is the force between those two charges. Now going to the part B of the question. This is the answer of part A. Now we are going to the part B of the question. Read the part B of the question. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is halved? So, doing two things, charge is doubled. So, the new q or q dash is equal to 2 times q. And the new, whatever the distance r dash, new distance r dash is r by 2. R by 2. So, we have to put these changes in the equation. Okay, so this was our equation. Let me add one page. Okay, so here the part B, we have in the part A the force is 1 by 4 pi epsilon 0 q square by r square here, because both the charges are equal. Now the new force is f dash is equal to 1 by 4 pi epsilon 0. There is no change in the constant. Q dash square by r dash square. What is here? What is the q dash here? It is 2 times q. What is r dash? R dash is r by 2. So you can substitute the values here. So it is 1 by 4 pi epsilon 0 2q whole square divided by r by 2 square, right? So if you simplify, you will get 1 by 4 pi epsilon 0 into 2 square is 4. 4 into q square, right? In the denominator, it is r square by 4, right? So altogether, we have 4 into 4. This 4 will come to the numerator, you know. So 4 into 4 is 16. So 16 times 1 by 4 pi epsilon 0 q square by r square. You know, this is the previous force. So 16 times F. The previous force we have calculated, it is 1.52 into 10 raised to minus 2, right? So if you multiply, you will get the answer. 16 times 1.52. It is 24.32 into 10 raised to minus 2 Newton. Okay, so this is the new force. This one you can adjust the point like 2.43 into 10 raised to minus 1. That also is fine. Or you can write 0.24, 0.24. That also is fine. Okay, so this is the new force. This is how we find the new force. So this is the second answer for the B part. Okay, now we'll go to the next question. This question also is an NCERT exercise question. It is very related to the previous question, or it is like a C part of the question. Suppose the spheres A and B in the above problem have identical sizes. Okay, so we are considering the same spheres in the previous problem. The two spheres have identical sizes. Okay, identical size are same. The third sphere of the same size but uncharged is brought into contact with the first, then brought in contact with the second, and finally removed from both. What is the new force of repulsion between A and B? So here you have to read the statement question carefully. A third sphere of the same size, you know, the charges on the spheres are this A, this B. On the charge on A is Q, that on B also is Q. Okay, there is a separation, you know. Here in this question, we don't change the separation, but what we do is that in the step 1, we bring we bring yeah, a third sphere, a third sphere, and what do we do? A third sphere of the same size but uncharged is brought in contact with the first one, brought in contact with the first one. So this C, the third sphere C, is brought in touch with the first one. In this case, what will happen after this process? What is the result of this process? What will be the result of this process? What is the result of this process? Think of it. Okay, I will write. Think of it. What is the result of this process? Now, what will be the new charge on A? A and C are brought in touch with each other. Okay, A and C are touch with brought in touch with each other. So, what will be the new charges on A and C? A had an initial charge Q and C had a charge 0. So, since these spheres are of identical size, when they brought in contact, these spheres are copper spheres, right? In this previous question, it was given. They're copper spheres. So, they are conductors. They are metal spheres. So, they are conductors. So, they will conduct the charges. So, what will happen is that the charge flows from A to C, and finally they will have the same charge. Both will have the same charge, or we can say that the two spheres will share the charge. So the final charge on A and C will be like this. It is 0 plus Q by 2. They will share the charge, and final charge will be Q by 2 on both. So C will get Q by 2 charge. The A will also get Q by 2 charge. Okay, then brought in contact with the second. Now C is brought in. So now the charge of A is Q by 2. Now C is removed from A and it is brought in contact with B. Okay, so I will draw that situation also. I will draw it here. Okay, so this is our B and C is this. B has a charge Q and C now has a charge. This is sequential process. First C was neutral, and then in the step one, what did we do? We brought C in touch with A, so C got a charge of Q by 2. So now C has a charge of Q by 2, and when B and C are touch each other, what will happen? Their charge will become average. How can we find the average? Q plus Q by 2 by 2. What will be that? What is Q plus Q by 2? 3Q by 2, right? Divided by 2. Okay, 3Q by 4. The result is 3Q by 4. Now, the result of this process is that B, both of them will have a charge of 3Q by 4. Both will get charge of 3Q by 4. 3Q by 4. I think you got the idea. Okay. So, the charges on B and C are now 3Q by 4. So, what is the charge on A? The charge on A is Q by 2 now. After uh, after touching with C, the charge on A has changed. It was initially it was Q, now it is Q by 2. Now the question is, what is the new force of repulsion between A and B? What is the new force of repulsion between A and B? So coming to the problem, Yeah, this is A, and B, they are at a distance of R as before. What was this R? You know, it is 0.5. It was given in the previous question, 0.5 meters. And now the charge of A is what? Q by 2, and that of B is 3Q by 4. Okay. So what is a new force? In the previous case, it was F dash. Now I will write F double dash. It is 1 by 4 pi epsilon 0. In the first case, it was Q square by R square, right? I am writing the same equation because both were the same. But here, the charges are different. Charges are different. So I will write Q1 into Q2. Q1 is Q by 2. Q2 is 3Q by 4, right? There is no change in the distance. We have to uh, take the same distance as in the first question. Okay, in the second question, the distance is reduced to half, but that will not affect this question. This is a separate question, C part of the question. Okay, it has to be done with the condition given in A. The other condition is only for B part of the question. So here you can find that what is the extra time coming. Here you can see that there is a 1 by 2 coming. 1 by 2, 1 by 2 is coming, this 1 by 2, and there is a 3 by 4 coming. Extra term is 3 by 4. So 1 by 2 into 3 by 4 can be taken out. So what is remaining? 1 by 4 p epsilon 0 q square by r square. So this is 1 by 2 into 3 by 4 is 3 by 8, right? 3 by 8 into, what is this quantity inside the bracket? This was the original force F. So 3 by 8 into that 1.52 into 10 raised to minus 2 Newton. So the final answer will be, I will calculate 1.52 into 3 divided by 8. Okay, so it's 0.57, 0.57 into 10 raised to minus 2 Newton. Now the force has been reduced because the charges has been reduced. Okay, so this is the final force. This is one of the answers, or answer of the C part. Answer of this question. This is separate. It is given as a separate question. The exercise, NCERT exercise. Okay, coming to the last question. Okay, this is a very important question. Very important question. Very conceptual question. Very important question. Read the question. The 2-point charges plus 16 microcoulomb and minus 10 microcoulomb are placed 8 centimeter apart in air. So I will draw the situation. There are 2-point charges. One is plus 10 microcoulomb and the other one is minus 10 microcoulomb. They are placed 8 centimeter apart. 8 centimeter is the distance between them. You are asked to place a plus 10 microcoulomb charge at a third position such that the net force on 10 microcoulomb charge is 0. Where will you place a charge? Make necessary calculation. So you are asked to place a third charge, which is 10 microcoulomb charge, plus 10 microcoulomb charge, such that the net force on that charge should be 0. Okay. Where can we place that 10 microcoulomb charge? Think of that. I will make several trials. Like, suppose I am placing the plus 10 microcoulomb charge here. Then will the net force on it be 0? You can think of that. The plus 10 micro, what will happen? Sorry, this is not plus 10, it is plus 16. Sorry, plus 16. This is plus 16 charge, plus 16, plus 16 and minus 10. Okay, the third charge is plus 10 microcoulomb. So if you place the 10 microcoulomb charge here, this charge will repel it in this direction, and the minus charge will attract it in this direction. So you have studied parallelogram law in the class 11. So what will be the result of this force? It will be like you have to complete the parallelogram, and it will be like this. Anyway, there will be a force. There will be a force. There will be a net force. The forces will not cancel each other. The forces will not cancel each other. If you place the plus 10 microcoulomb charge here, the force, similar is the situation. The forces will not cancel each other. So what is the other option? The possible options are, we can place the 10 microcoulomb charge. We can place the 10 microcoulomb charge at any point on this line. On this line means in between the charges, somewhere, anywhere here. Okay. Or on the right side of this minus 9 microcoulomb charge, or on the left side of plus 16 microcoulomb charge. Okay. So suppose you are placing the plus 10 microcoulomb charge somewhere here. You know it's a positive charge. So the plus 16 microcoulomb charge will repel this charge. The plus 60 microcoulomb charge will repel this charge. But this minus 10 microcoulomb charge will attract this. Okay. So the forces will be added. So the net force cannot be zero when a plus 10 when a positive charge is placed in between this opposite charges. Opposite means one is positive and the other is negative. So this is not possible. The plus 10 microcoulomb charge cannot come to an equilibrium, or the force on it cannot come to the zero value if it is placed in between the charges, because the forces will be added when it is placed in between the charges. So what is the next option? The next option is that it can be placed somewhere on this line. Let that plus 10 microcoulomb charge is placed here. Let this distance is x or y you can take. Okay, then the plus 60 microcoulomb charge, what is the force of plus 16 microcoulomb charge on this plus 10 microcoulomb charge? Both are positive charges, so this plus 16 microcoulomb charge will repel it. Yeah. The repulsion due to plus 16 microcoulomb charge. And what about the minus 9 microcoulomb charge? That will attract this plus 10 microcoulomb charge, because it is a negative charge. This is a negative charge. They are opposite charges, so that will attract. So here there is a chance for the forces to be cancelled each other, because these two forces are in the opposite direction. Okay. So the force, you have to place the positive charge, or the third charge, on the line joining these two charges, and beyond the charges, no, not in between the charges. If they are placed in between the charges, the forces will not be cancelled. We have to place a charge outside the two charges. You can place here or somewhere here, but this is not possible. Why? Because the 16 microcoulomb charge is a stronger charge as compared to, I'm telling about the magnitude, as compared to the minus 10 microcoulomb charge. So if you place that charge, whatever be the value, the forces will be opposite. But this minus 10 microcoulomb charge, since it is smaller and the distance is larger, so for this charge, this side is not favorable, because it is a smaller charge as well as the distance is higher. So the force will be less. It cannot compensate the the repulsion due to the 16 microcoulomb charge here, because the force of attraction due to this minus 10 microcoulomb charge will be much less as compared to the force of repulsion due to plus 16 microcoulomb charge. So the only possibility in this case is on this side. And now we have to find the distance. Now we have to find the distance x. That is our question. So we understood that we have to place the plus 10 microcoulomb charge beyond the minus 10 microcoulomb charge on its side. Okay. So let us do the calculation. Now the net force on this should be 0. For that, the force due to the positive charge, let me write F plus or F16 also will do, and force due to the negative charge should be balanced. F plus 6 plus 16, I will write like this, plus 16. F minus 10 should balance. So what is force due to F plus 16 on this 10 microcoulomb charge? It is 1 by 4 pi epsilon 0, the constant, and 16, actually it is microcoulomb. 1 microcoulomb is micro means 10 raised to minus 6, right? Coulomb. So you have to convert it into coulomb, but in this problem there is no need to convert, because the on both sides there are forces. If you put the values in microcoulomb on both sides, they will cancel each other. Similarly, the distance can be put in centimeter itself. They will cancel each other. There is no need to convert. So 16 into the other charge q1, this is q1. When we consider these two charges, this is q1 and this is q2. So 9 divided by distance square. What is the distance? 8 centimeter plus x. Okay, the total distance is 8 centimeter, 8 plus x, the whole square, distance square. Okay, I think you remember the equation 1 by 4 p epsilon 0 q1 q2 by distance square. Okay, that is equal to what force? 1 by 4 p epsilon 0. What is the force due to minus 10? We have to write only the magnitude, because the forces are opposites. That is why we are equating the forces. The forces are equal and opposite. So now we are considering the force between this minus 10 and plus 10. So what is the distance between them? X only. So 9 into 10 divided by x square. Okay. Now cancel the common terms on both sides. 1 by 4 pi epsilon 0 will be cancelled. Sorry, I have made a mistake. What is a mistake? Previously, I wrote the force between these two, but here I wrote 9. It is 10 itself. 10 itself. This is the first case. And the second case, I am writing force between 9 and 10. Okay, that is fine. So when we cancel it, this will be cancelled. The 10 will be cancelled. And you will get 16 by 8 plus x whole square is equal to 9 by x square. This step is very important. At this step, what you have to do is that take the square root on both sides. Taking square root on both sides of the equation, we will get, what is the root of 16? 16 is 4. The root of 16 is 4. 8 plus x whole square, 8 plus x. On the right hand side, taking the root, 9, the root of 9 is 3. X square, for x square, it is x. Now this equation has become simple. Otherwise, you will cross multiply and expand. Then it will be a plus b whole square, and square terms. Then it will be quadratic. The problem becomes more difficult. So you have to, I am putting a star because you have to remember that at this step what you have to do is take the square root on both sides. So now take cross multiply. 4x is equal to what? 3 into 8 plus x. Okay, simplify this. 4x is equal to 3 into 8 is 24, right? Plus 3x. So if you take 3x to the left hand side, it is 4x minus 3x is x. X is equal to 24 in centimeter, because we have substituted the distance in centimeter. So 24 centimeter. So what did we get? And you have to write the answer like this. So the plus 10 microcoulomb charge given, the third charge, plus 10 microcoulomb charge given, should be placed at a 24 at a distance of 24 centimeter from what? From this minus 10 microcoulomb charge. Okay. And what should be the distance from the plus 16 microcoulomb charge? It is 24 plus 8. 24 plus 8 is 32. So the plus 10 microcoulomb charge should be placed on the line joining the charges at a distance of 24 centimeter plus from the minus 10 microcoulomb charge, and at a distance of 32 centimeter from the plus 16 microcoulomb charge. So there is no confusion. One person reading that answer can easily uh, locate the point. Okay, so this is the answer, and that sentence also is very important. So we have to place the plus 10 microcoulomb charge at a distance of 24 centimeter from the minus 10 microcoulomb charge, and a distance of 32 centimeter from the plus 60 microcoulomb charge, in order to uh, be the force on this charge 0, or uh, in order that this charge is in equilibrium. Okay, so the problems are over. These are the problems related to Coulomb's law. Okay, these are very important problems. So practice the problems, and write down the formulas, as I told you in the last class, on a formula book. Practice these problems. Problems are very important in physics. So what you have to do is that you write down the physics, write down the problems and equations. Then you can easily remember the equation. Then physics will be easier. Okay, write down and study. Okay. Okay, thanks for watching this class. We will meet in the next class. Thank you.